Hello students. So today we are doing this integration by parts. So in the last online class also we were doing the same topic, that is integration by parts. So today we will do from this 5 marks section. Same exercise, exercise 7, page number 381 from the book Higher Mathematics for Class 12 by Sailendra. So let's do this question number 1. So let us integrate this function. So it is given integral of x square sin inverse x dx divided by 1 minus x square whole to the power 5 by 2. So let us integrate it. So first of all, let us write I is equal to integration of x square sin inverse x dx divided by 1 minus x square whole to the power 5 by 2. So now how can you evaluate this integration? Now first of all you have to do the method of substitution. So you know that what is the differentiation of sin inverse x? Differentiation of sin inverse x is, you know that it is 1 upon root over 1 minus x square. Okay, what is the differentiation of sin inverse x with respect to x? It is 1 upon root over 1 minus x square, right? So now in this case 1 minus x square whole to the power 5 by 2 is there. So let us write it in terms of 1 minus x square, that is root under 1 minus x square, and some expression will be there. So you can break this term 5 by 2. So 5 by 2 can be written as 2 plus half, isn't it? Let us write this 1 minus x square in terms of whole to the power half also. So we may write 5 by 2 as 2 plus 1 upon 2. What is 2 plus 1 upon 2? 2 to the 4 plus 1, 5 by 2. So let us write this 5 by 2 as 2 plus 1 upon 2. So or I is equal to integral sin x square sin inverse x dx divided by, this is 1 minus x square whole to the power 2 plus half. So this 5 by 2 is written as 2 plus 1 upon 2. So you can break this expression, isn't it? How can you break this expression? How can we separate this expression? 1 minus x square whole square into 1 minus x square whole to the power half. Right? So let us write here I is equal to integration of x square sin inverse x divided by 1 minus x square, this is your whole square, 1 minus x square whole to the power half, then dx. So why are we writing this denominator as 1 minus x square whole to the power half? Because this 1 minus x square to 1 minus x square whole to the power half can be written as within square root 1 minus x square, right? And you know that the differentiation of sin inverse x is 1 upon root over 1 minus x square. That's why this 1 minus x square whole to the power 5 by 2 can be written as 1 minus x square whole square into 1 minus x square whole to the power half. Is that clear? So now in the next step, I is equal to integral sin x square sin inverse x dx divided by 1 minus x square whole square. Now this is root over 1 minus x square. Is that clear? So now you can do the method of substitution in this case. That is, we can assume sin inverse x as z, because the differentiation of sin inverse x with respect to x is 1 upon root over 1 minus x square, right? So let us write here, let z is equal to sin inverse x. So now what will you do? You can differentiate both the sides with respect to x. So differentiating both the sides with respect to x. So it is dz by dx is equal to 1 upon root over 1 minus x square. Is that clear? So next, let us get the value for only dz. dz is equal to, this is dx upon root over 1 minus x square. Is that clear? So let us put these values in I. Before that, we have to put the value for x here also, isn't it? There is x square upon 1 minus x square whole square. You have to express it in terms of z, right? So here we had assumed, let z is equal to sine inverse x. So from here, what is the value for x? X is equal to sine z, isn't it? So now let us put these values in I. So therefore I is equal to integration of, what is x square? X square is sine square z. Let us write here sine square z into, what is sine inverse x? Sine inverse x is z, right? Next, what is dx upon root over 1 minus x square? What is dx upon root over 1 minus x square? It is dz. This whole divided by, within bracket, there is 1 minus x square whole square. You have to put x is equal to sine z in this case. 1 minus sine square z whole square. And we have already written instead of dx upon root over 1 minus x square as dz, isn't it? So I think you have understood it. Let us simplify it. Or I is equal to integral sine, let us write down z first, then sine square z dz divided by, let us simplify it. What is 1 minus sine square z? It is cos square z, right? 1 minus sine square z is, you know that, cos square z, and whole square is cos to the power 4z. It is cos to the power 4z. So I think you have understood it. So let us simplify this, sine square z by cos to the power 4z. So how can we simplify it further? I is equal to integration of z. This is your sine square z. Let us separate this term. Sine square z by cos square z into what? 1 upon, this is cos square z. Then what do we write? dz. So I hope you have understood it. We are just simplifying it, right? So or I is equal to integral sine z into, what is sine square z by cos square z? That is your tan square z. And what is 1 by cos square z? That is your sec square z dz. This is your sec square z dz. This is square. So I think you have understood it. Now this is integration of the product of two different functions. So which are the functions out here? So in this case you have to use integration by parts formula, right? So what is z? Z is algebraic function, that is a, and tan square z, sec square z is trigonometric function, that is t. So there are two functions out here. One is algebraic function a and the other one is trigonometric function t. So among these two letters a and t, which letter comes first in the word liet or islet? This a comes first, isn't it? That means a means algebraic function, that is z is the first function, and tan square z, sec square z is the second function. So let us use integration by parts in this case. So therefore I is equal to, so z is first function is taken outside, integration sign, which is the second function, that is tan square z into sec square z dz minus, okay, then integration of second bracket opened d by dz of z, that is d by dz of the first function, that is z, then again integration of the second function, that is tan square z sec square z dz, second bracket closed, then what do we write? dz. So this is your integration by parts, okay? Now again you have to evaluate this integration. That is integration of tan square z, sec square z dz. You cannot write down its integration directly. There also within integration there is another integration, that is integration of tan square z sec square z dz. In this case also this is the same integration. In this case also we cannot directly write down its integration. So let us find out its integration first. So let us take it outside. So let I1 is equal to integration of tan square z sec square z dz. So how can you evaluate this integration? So you know that differentiation of tan z is sec square z, isn't it? So you can do method of substitution in this case. So let us write t is equal to tan z. So let us write down the new variable out here, t. Let t is equal to tan z. Now let us differentiate it. Differentiating both the sides with respect to z. So therefore dt by dz, what is the differentiation of tan z? That is your sec square z. Let us do cross multiplication. So dt is equal to, this is your sec square z dz. So I hope you have understood it. Okay, so therefore what is I1 now? Integration of what is tan square z? This is t square into what is sec square z dz? It is dt, right? So or what is I1 is equal to, this is t cube divided by 3. That is, this is just like your x to the power n dx. That is x to the power n plus 1 divided by n plus 1. But here it is t cube upon 3. Then what do you write? Plus c. Or I1 is equal to, what is t cube out here? It is tan cube z. It is tan cube z divided by 3 plus c. So we have got the value for I1. Actually, this is the integration of tan square z sec square z dz. So let us put these values in I. Okay. So therefore, what is I now? I is equal to z into, what is integration of tan square z sec square z dz? What is it? This is actually tan cube z upon 3. This is actually tan cube z upon 3. But don't write plus c out here. So in the previous problem also we integrated it directly, but we don't write down there c. Isn't it? We did not write c in that case. Okay. So here also don't write down c in this case. Right. So what is integration of tan square z sec square z dz? It is tan cube z upon 3. But don't write c in this case. Okay. Minus integration of d by dz of z is 1. You don't have to write it. What is integration of tan square z sec square z dz? Again, it is tan cube z by 3. It is tan cube z by 3. Then what do we write? dz. So I think you have understood it. Okay. So now in this case, you have to evaluate this integration. That is integration of tan cube z dz divided by 3. Okay. So or I is equal to z tan cube z upon 3 minus 1 upon 3 integration of. So how can you evaluate this integration of tan cube z? Okay, and let us break this term tan cube z. Let us write it as tan z into tan square z. Let us write it as tan z into tan square z dz. Okay, so tan cube z we can separate it as tan z into tan square z. As you know that the differentiation of tan z is sec square z. But here we have got tan square z. Let us change this tan square z into sec square z. Okay. So what is the formula for tan square z? In terms of sec z, it is tan square z is equal to sec square z minus 1. So let us write here I is equal to z. This is your tan cube z upon 3 minus 1/3 integration of, this is your tan z. Right? What is tan square z? it is sec square z minus 1 bracket close dz. Is that clear now? So or I is equal to, now this is z tan cube z upon 3. Is that clear to all of you? So minus 1/3 integration of, this is your tan z sec square z dz. All right. So as there is no space out there, let us write it in the next step. So minus into minus is plus. So this is 1/3 integration of, this is tan z dz. So I think you have understood it. So we have got I as z tan cube z by 3 minus 1/3 integration of tan z sec square z dz minus into minus plus 1/3 integration of tan z dz. Okay. So now, so how can you evaluate this integration? We can directly integrate it now. Since we have done many type of integration, so we can easily integrate this function without assuming tan z as some other variables, isn't it? So you know that differentiation of tan z is sec square z. If you assume this tan z as t, if you assume this tan z as t, what is the differentiation of tan z? It is sec square z. That is, you will get t dt, isn't it? Here also let us write u is equal to, we have already assumed t out here. Let us assume u is equal to tan z. So du by dz is equal to sec square z. If you cross multiply, you will get du is equal to sec square z dz. So this will be u du, isn't it? What is the integration of u du? U square upon 2. But what is u here? It is tan z. Understood? So again I am explaining you. So how can you evaluate this integration? Let us assume u is equal to tan z, because differentiation of tan z is sec square z, right? So let u is equal to tan z. So du by dz is equal to sec square z. If you cross multiply, you will get du is equal to sec square z dz. So instead of sec square z dz, you can write du, and this is u. What is integration of u du? U square by 2. Is that clear? So in this case, u is tan z, so it is directly integrated. So I is equal to z tan cube z upon 3, right? So minus, this is 1/3 into, this will be tan square z divided by 2. That is u square by 2. U means tan z, so it is tan square z by 2. Then plus, what do we write? Then plus integration of tan z. What is integration of tan z? It may be minus log within mod cos z, or it may be log within mod sec z. Let us write minus log within mod cos z. So it will be minus 1/3 log within mod cos z, the base is e, then what do we write? Plus c. So this is the value for I, but it is in terms of z, but you should write it in terms of x. Okay. So let us write down the next step out here. So or I is equal to, now this is, or I is equal to z tan cube z upon 3, right? Next minus 1/6, this is your tan square z, then minus 1/3 log within mod cos z, the base is e, then what do you write? Plus c. So this is I, but it is in terms of z, but you should write it in terms of x. Okay. So how can you write it in terms of x now? So we know the value for sin z out there, isn't it? What is sin z is equal to x. Let us convert this tan z and cos z in terms of sin z. So or I is equal to, what is z here? So let us write 1/3 first. What is z? This is your sine inverse x, right? Into within bracket, this is tan z whole cube. You can write it as sin z by cos z whole cube. minus 1 by 6. This is your sine z upon cos z whole square, minus 1/3. This is log within mod. This is root over 1 minus sine square z, isn't it? This is sine square z, right? The base is e, then plus c. Is that clear now? So I think you have understood it. Now again you have to convert this cos z into sin z. Or I is equal to, this is 1/3. This is your sine inverse x within bracket. What is sin z? Sin z is x divided by root over, this is your 1 minus sine square z whole cube minus 1 by 6 within bracket. What is sin z? This is x divided by root over, this is your 1 minus sine square z whole square minus 1/3 log base e within mod root over, this is 1 minus x square plus c, because here sin z is x. Is that clear? Next, or I is equal to, this is 1/3. This is your sine inverse x within bracket x upon root over 1 minus, what is sin z? That is your x. Here sin z is x, so it is x square. This is your whole cube minus 1 by 6 within bracket x upon root over 1 minus x square, this is whole square. Then minus 1/3 log base e within mod, you can write within square root. Within square root means whole to the power half. 1 minus x square, this is whole to the power half, mod sign close, plus c. Okay, so or now this is I is equal to 1/3 into, let us write down this first. This is x cube into sine inverse x, right? X whole cube is x cube, then sine inverse x divided by, this root over means whole to the power half, but there is whole to the power 3, so it can be written as 1 minus x square whole to the power 3 by 2 minus 1 by 6 into, what is it? This is x square divided by, this is your 1 minus x square, right? So that is root over 1 minus x square, whole square is 1 minus x square. Minus, now because of this log, you can use the properties of logarithm. This power half becomes a coefficient. Because of this log, using properties of logarithm, this power half becomes a coefficient. So half into minus 1/3, that is 1 by 6 log within mod 1 minus x square, the base is e, then plus c. So this is the final answer. So I think you have understood it. This is quite lengthy and quite difficult, but you can do this problem. Okay, so again you have to revise it at home. So you can copy it. So you can revise it at home, because this is quite complicated and quite lengthy. So, but you can do it. Okay, so you can copy it now. So now this question number 2 will be a homework. That is, you have to integrate cosec square x log sec x dx. You can directly use integration by parts in this case. So this is your homework, right? So let's do this integration of the form integral sine e to the power x within second bracket f of x plus f dash of x second bracket close dx. But we have done this type of problem in method of substitution also. So you have to do it using method of integration by parts also. We can evaluate this integration using integration by parts also, right? So we have to use this method in this case, that is integration by parts. So let us write it first as this is integration of e to the power x within second bracket f of x plus f dash of x second bracket close dx. So let us write it as I is equal to integration of e to the power x within second bracket f of x plus f dash of x second bracket closed dx. Okay. So now in this case we are using the method of integration by parts, right? So first of all you have to check this function. So what is the relation between f of x and f dash of x? You know that differentiation of f of x with respect to x is f dash of x. That is, differentiation of the first function is the second function, right? So what will you do here is, let us multiply by e to the power x first and then let us separate this integration. So there are, this is sum of the two integration. And now since we know that differentiation of the first function is the second function, so you have to use integration by parts for the first function only, because differentiation of the first function is the second function. That's why you have to use integration by parts for the first function only. Okay, let us simplify it first. Therefore I is equal to integration of within second bracket, this is e to the power x f of x plus e to the power x f dash of x second bracket close dx. Okay, now let us separate integral sign and dx also. I is equal to integration of e to the power x f of x dx plus integration of e to the power x, this is your f dash of x dx. So I think you have understood it. We are just simplifying it. Okay, as you know that differentiation of f of x is f dash of x. Forget about e to the power x, right? That is the differentiation of this first function f of x is the second function, that is f dash of x. So you have to use integration by parts for the first function only and keep the second integration as it is. Is that clear? That is the method in this case. Is that clear? So let us use integration by parts for the first function only. So e to the power x is the exponential function. We can take it as f of x as algebraic function. So e to the power x, always take it as the second function and f of x as the first function. This f of x may be your logarithmic function. This f of x may be inverse circular function. F of x may be your trigonometric function. F of x may be your algebraic function. Okay, so let us take this f of x as the first function and e to the power x as the second function. So let us use integration by parts for the first function only, but you have to keep the second term as it is. Don't use integration by parts for the second function. Is that clear? Because differentiation of the first function is the second function. That's why we are using integration by parts for the first function only. Is that clear? So let us use integration by parts for the first function. So I is equal to, here f of x is the first function, it is taken outside, integral sign e to the power x dx. Is that clear? Then minus sign, integration of second bracket dy dx of, this is f of x, integration of e to the power x dx second bracket close dx. So this is your method of integration by parts. Now keep the second term as it is. What is the second term out here? Plus integration of, this is e to the power x into f dash of x dx. So I think you have understood it. Okay, so or I is equal to, now let us first integrate e to the power x dx. What is this integration? E to the power x, then f of x minus integration of, what is dy dx of f of x? You know that this is f dash of x into, what is integration of e to the power x dx? That is your e to the power x. Then we can write dx here plus integration of e to the power x into f dash of x dx. Understood now? So, or I is equal to e to the power x f of x minus integration of e to the power x f dash of x dx plus integration of e to the power x f dash of x dx. Is that clear now? So now let us simplify here. So now in this case, you can cancel this second and third term. Cancel it. Okay. So I is equal to, the remaining term is e to the power x f of x plus c. So this is the final answer. This is the method for evaluating this integration of this type. So I think you have understood it. So you can copy it. Now we will do some problems relating to this method. Okay. So now we'll do the next question, that is question number 3. That is, you have to evaluate this integration. That is integration of e to the power x upon x into, within bracket, in the numerator there is x log x plus 1 bracket close dx. So let us first write I is equal to integration of e to the power x upon x within bracket x log x plus 1 bracket close dx. Okay. So let us first simplify it. Let us multiply this x log x plus 1 by e to the power x by x. Okay. So I is equal to integration of, within bracket, if you multiply x log x by e to the power x by x, x will be cancelled. You will get e to the power x log x plus e to the power x by x into 1 is e to the power x upon x bracket closed. Then what do we write? Dx. Is that clear to all of you? So now we can use the previous method. Just now we have done the method, isn't it? So let us consider only log x and 1 upon x. Let us forget about e to the power x for the time being. Okay. Let us forget about e to the power x. Just consider this expression log x and 1 by x. So what is the relation between log x and 1 upon x? That is, differentiation of log x is 1 upon x. That is, differentiation of this function is 1 upon x. So let us separate the term first. So now, since differentiation of the first function is the second function, so you have to use integration by parts for the first function only, but you cannot use integration by parts for the second function. Is that clear? So let us separate the term now. Or I is equal to integration of e to the power x log x, then dx, plus integration of e to the power x upon x, then what do we write? Dx. Is that clear to all of you? I think you have understood it. Okay. So now, keeping the second integration as it is, let us integration by parts. Let us do integration by parts for the first function, because differentiation of log x is 1 upon x. That is, log x is the first function here and 1 by x is the second function. That is, differentiation of log x first function is the second function 1 by x. That's why you have to use integration by parts for the first function only, but don't use integration by parts for the second function. You have to keep it as it is. Okay. So, or I is equal to L and E. E to the power x is the exponential function, that is your E. Log x is the logarithm function, that is L. So in the word let or I let, L comes first. That's why this log x is the first function and e to the power x is the second function. You know that, isn't it? So let us use integration by parts for the first function only. So log x is taken outside, integration of e to the power x dx minus integration of second bracket e to the power x, oh sorry, that is log x is the first function. Here you have to take the differentiation of the first function, that is log x with respect to x. Within second bracket, dy dx of log x, integration of, this is e to the power x dx, second bracket closed, dx. Is that clear now? So this first function is done, and that is in the first function we have used integration by parts. Now keeping the second term as it is, plus integration of e to the power x divided by x dx. Is that understood? So now, or I is equal to, so let us first integrate e to the power x dx. So what is this integration? E to the power x, e to the power x log x, right? Then minus integration of, minus, this is integration of, what is dy dx of log x? 1 upon x. Let us write 1 upon x here into, what is integration of e to the power x dx? This is again e to the power x. Then we can write dx, and keeping the last term as it is, plus, what is the last term here? Integration of e to the power x divided by x dx. Understood? So next, or I is equal to e to the power x log x minus integration of e to the power x upon x dx plus integration of e to the power x upon x dx. So here you can cancel these two integrations. Or I is equal, now we have finished integration in this case, so you have to write down plus c in the answer. So this is the final answer. So I think you have understood it, so you can copy it. Now we'll do the next question. So now we'll do the next question, that is question number 4, number 1. You have to evaluate this integration. That is integral of within third bracket 1 upon log x minus 1 upon log x whole square third bracket close dx. So let us evaluate this integration. Okay. So let us write first I is equal to integration of within third bracket 1 upon log x minus 1 upon log x whole square third bracket close dx. So in this case we don't have e to the power x, but in this case also we can use the same method as we are doing in the previous problems, right? So let us take this log x as x. Let us take for the time being log x as x. So this is 1 upon x. Okay. So I told you about the differentiation of 1 upon x to write it directly as minus 1 upon x square, isn't it? What is dy dx of 1 upon x? It is minus 1 upon x square. You know, how did you get that minus 1 upon x square, isn't it? 1 upon x is actually x to the power minus 1. When it is taken to the numerator, it becomes x to the power minus 1, right? So what is the differentiation of x to the power minus 1? Minus 1 becomes the coefficient, then x to the power decrease the power by 1, that is minus 1 is minus 2. So this is minus 1 x to the power minus 2, which is simplified as minus 1 upon x square. Now in this case we have taken log x as 1 upon x. This log x as x, this log x is taken as x, so this is 1 upon x and this is minus 1 upon x square. That is differentiation of 1 upon x is minus 1 upon x square. That is differentiation of the first function is the second function, isn't it? So let us separate it first, and then you have to use integration by parts for the first function only, but you have to keep the second integration as it is. Don't use integration by parts for the second function, keep it as it is. Okay. So now let us separate the term now. I is equal to integration of 1 upon log x dx minus integration of 1 upon log x whole square dx. So I think you have understood it. Okay, since differentiation of the first function is the second function, so use integration by parts for the first function only and keep the second term as it is. Don't simplify the second term in this case. That is the method, isn't it? So this is log x is the only function here. I told you that if there is integration of only log x function, then also you have to use integration by parts. That is 1 by log x into 1 is there. 1 by log x is logarithmic function and 1 is algebraic function. So L comes first in the word let or ilet. So 1 by log x will be the first function. Okay. So it is taken outside. I is equal to 1 upon log x integration of dx, right? Minus integration of second bracket. This is dy dx of first function, that is 1 by log x. Actually 1 by log x is, it is log x whole to the power minus 1. It is taken to the numerator so that it will be easier for you to differentiate log x whole to the power minus 1 with respect to x. That's why this log x is taken to the numerator, right? So this is integration of dx, second bracket closed, dx. So this is your integration by parts. Now the second term is kept as it is, minus integration of 1 upon this is your log x whole square dx. It is kept as it is, right? So let us simplify it first. I is equal to, what is integral sign dx? That is your x divided by log x minus integration of, what is dy dx of log x whole to the power minus 1? It is just like your x to the power n. We can assume log x as x. So this is your x to the power n form. What is this differentiation with respect to x? N into x to the power n minus 1. But here it is minus 1 log x whole to the power minus 2 into, again you have to differentiate the term which is assumed as x. So in this case log x is assumed as x. So again you have to differentiate this function. So what is the differentiation of log x? 1 upon x into, what is integration of dx? X dx minus integration of 1 upon log x whole square dx. Understood? So now here x gets cancels, that is 1, or I is equal to, so now this is x by log x, this is x by log x, right? So minus into minus plus, plus integration of, let us simplify it, minus into minus plus integration of log x whole to the power minus 2 is 1 upon log x whole square. So it is 1 upon, this is your log x whole square. Then what do we write? Dx. Then we write dx here minus integration of 1 upon log x whole square dx. 1 upon, this is log x whole square dx. So I think you have understood it. So you can cancel this second and third term plus minus, okay? Or I is equal to, what is the final answer now? This is x upon log x plus c. So this is the final answer. So I think you have understood it. So you can copy it. Now we'll do the next question. So now we'll do the next question, that is for number 2. You have to evaluate this integration. That is integral of within third bracket log of log x plus 1 upon log x whole square, third bracket is closed, dx. You can use the same method as we have done it in for number 1. Okay, so this question is very important and this question is from higher secondary question paper, but I don't know exactly in which year this question was given, but this question is from HS question paper. So this is very, very important question. Okay, so you can use the same method as we have done it in for number 1. Okay, so now let us write first I is equal to integration of within third bracket log of log x plus 1 upon log x whole square third bracket is closed dx. So in this case also, first of all you have to separate this integral sign and dx, that is it will be integral sign log of log x dx and integral sign 1 upon log x whole square dx. So in this case also, for the first function you have to use integration by parts, keeping the second term as it is. So this method is used, that is the same method is used as we have done in for number 1. Okay, so let us separate this function first. I is equal to integration of, this is log of log x dx, okay, minus integration of 1 by log x whole square dx. Okay, but we know that differentiation of log x is not 1 by log x whole square, but while integrating it log of log x, you may not get 1 upon log x whole square, but if you again integrate that function, so after integration you will get some function here. If you integrate that function, you might get 1 upon log x whole square. Is that clear? That's why you have to integrate it by parts. That is, the first function should be integrated by parts, keeping the second term as it is. Okay, so or I is equal to, for the first function use integration by parts. This is the first function, that is log of log x will be the first function, 1 will be the second function, you know that. So log of log x integration of dx minus integration of second bracket, this is d by dx of log x, then integral sign dx second bracket close dx. Understood? Now second term is kept as it is. Don't simplify it. If you simplify it, you will not get the answer. Again, if you use integration by parts for this function, you will not get the answer. It will be complicated. You will not get any answer in that case. Okay, so second term is kept as it is, minus 1 upon, this is log x whole square, then dx. Is that clear? So next, or I is equal, let us first integrate. What is integral sign dx? This is x log of log x, right, minus integration of, what is d by dx of log x? It is just like your log x form. What is the differentiation of log x? 1 upon x, but here it is log x. Again differentiate the term which is assumed as x. Your log x was assumed as x. What is the differentiation of log x with respect to x? It is 1 by x into, what is integral sign dx? That is your x dx minus integration of 1 upon log x whole square dx. So here you can cancel this x. Okay, so let us write down the remaining term here. I is equal to, what is it now? First function x log of log x, x log of log x minus integration of, what is here? 1 by log x dx, right, and minus, here also minus sign is there, isn't it? Minus, this is minus sign, oh this is not minus, this should be plus, sorry, this is plus sign, right? This is also plus sign, there is plus sign here, plus sign, this is also plus sign. So it is plus 1 upon integration of, this is 1 upon log x whole square, 1 upon, this is log x whole square dx. Is that understood now? So now in this case, minus 1 upon log x is there, and there is plus 1 upon log x whole square. So let us assume this log x as x. So this is your minus 1 upon x, and this is your plus 1 upon x square. Now we know that differentiation of minus 1 upon x is plus 1 upon x square, isn't it? What is the differentiation of 1 upon x? It is minus 1 upon x square. But what is the differentiation of minus 1 upon x? It will be plus 1 upon x square. That is, differentiation of the first function is the second function. So let us use integration by parts for this function, keeping this function as it is. Is that clear? Now let's use the method now. Or I is equal to x log of log x minus, let us use integration by parts for this function. So 1 by log x is taken outside, integration of dx minus integration of second bracket, this is your dy dx of, we can take log x to the numerator, so it becomes log x whole to the power minus 1. Right, then integration of dx, second bracket closed, dx, then third bracket is also closed. So for this function we have used integration by parts. Plus the last term is kept as it is, integration of 1 upon, this is your log x whole square, then this is dx. Is that understood? So now let us simplify it once again. I is equal to x log of log x minus, within third bracket, let us integrate dx, that is x upon log x, minus integration of, what is dy dx of log x whole to the power minus 1? How can you differentiate it? It's just like your x to the power n, log x is taken as x, so it is x to the power n. What is this differentiation? Power becomes the coefficient, your x is log x whole to the power, decrease the power by 1, that is minus 1 is minus 2, into, again you have to differentiate the term which is assumed as x. Here log x was assumed as x. What is this differentiation? It is 1 upon x, into, what is integral sign dx? That is your x. Then we write dx. Third bracket is closed. Then plus integration of, this is 1 upon log x whole square. Then what do you write? Dx. So I think you have understood it. Okay. So now in the next step, or I is equal to, this is x log of log x minus, within third bracket, x upon log x, right? So this is minus into minus, plus integration of here, this xx will be cancelled. So what is log x whole to the power minus 2? It is 1 upon, this is log x whole square, right? Then you have to write down dx. So here third bracket is closed, and what is the last integration? Plus integration of 1 upon, this is your log x whole square dx. Understood now? So let us open this bracket, let us simplify it. Or I is equal to x log of log x, right? Then minus x upon log x, minus x upon log x, minus into plus, minus integration of, what do we write here? 1 upon log x whole square dx, right? Plus, this is integration of 1 upon log x whole square dx. So I think you have understood it. Okay. So let us cancel it. We can cancel these similar terms, but they are of opposite sign. Okay. So what is the final answer now? Or I is equal to x log of log x, right? Minus, this is x upon log x. Then what do you write? Plus c. So this is the final answer. So this question is very, very important. You can practice at home. So you can copy it. Now we'll do the next question. So now we'll do the next question, that is question number 5. So you have to evaluate this integration. The question is integration of e to the power x within bracket 1 upon x minus 1 upon x square dx. Okay, so let us first write I is equal to integration of e to the power x within bracket 1 upon x minus 1 upon x square dx. So how can you evaluate this integration? Now there is a function, exponential function e to the power x, and within bracket we have 1 upon x minus 1 upon x square. Now within bracket you should know the relation between these two functions, that is 1 upon x and minus 1 upon x square. And you know that differentiation of 1 upon x is minus 1 upon x square, right? So let us first multiply it by e to the power x, and then you can separate this integral sign and dx also. And since differentiation of the first function is the second function, you have to use integration by parts for the first function, keeping the second term as it is. You cannot use integration by parts for the second function. Okay, so or I is equal to integration of within bracket, let us multiply it, e to the power x upon x minus this is e to the power x upon x square bracket closed dx. Understood? Now let us separate integral sign and dx also. I is equal to integration of e to the power x divided by x dx minus integration of e to the power x upon x square dx. Is that clear? So as I already told you that differentiation of the first function 1 upon x is the second function, that is minus 1 upon x square. So let us use integration by parts for the first function only, keeping the second term as it is. That means you cannot use integration by parts for the second function, right? So let us use integration by parts for the first function only. 1 upon x, you know that is algebraic function a. E to the power x is exponential function, that is e. So among these two letters a and e, which letter comes first in the word liet or islet? That is a comes first, obviously, right? So 1 upon x is the first function and e to the power x is the second function. Okay, so therefore I is equal to 1 upon x is taken outside, integral sign e to the power x dx. Okay, then minus sign, integration of dy dx of this is your 1 upon x, right? Then integration of e to the power x dx second bracket close dx. So now we have used integration by parts for the first function. Okay, now keep the second term as it is, minus integration of e to the power x divided by x square dx, right? So or this is I is equal to, now you first integrate, what is integral sign e to the power x? E to the power x upon x minus integration of, so you can directly differentiate 1 upon x with respect to x. What is it? Minus 1 upon x square into, what is integration of e to the power x? E to the power x dx minus integration of e to the power x upon x square dx, right? So or this is I is equal to e to the power x upon x minus into minus plus integration of e to the power x upon x square dx minus integration of e to the power x upon x square dx. Now here you can cancel this two integration. So what is the answer now? I is equal to e to the power x upon x plus c. So this is the final answer. So this question is also very, very important. So you can mark it. Okay. So I think you have understood it. So you can copy it. Now this much is for today. त आज पनि हामीले जतिवटा प्रब्लम गर्यौं यो सबै अलिक लेन्दी टाइपको पनि छ. सो नम्बर 1 इज क्वाइट लेन्दी. So you can revise all the problems that we did today, and in the next online class we will do more problems on this integration by parts. So this much is for today.